Hi everyone, my name is Oluwatosin Bodunrin. I am one of the AESA-ARISE grantees of the African Academy of Sciences located in Nairobi, Kenya. I am also a senior lecturer at the University of the Witwatersrand in Johannesburg, South Africa. What does engineering innovation for a more resilient world mean to me? I think the World Engineering Day celebration has really taken a very good theme for the year. And sincerely, I think that considering what happened in Turkey and Syria recently, this should be a call to all engineers out there. I think that a resilient world is a world that is able to adapt to drastic changes that is happening. It's able to adapt to several challenges confronting it and able to overcome all of it. I mean, all of it. But to be able to do that, we need to change our approach to developing engineering solutions or engineering innovation. Our approach has always been reactive. So when there is a problem, then we start rallying around on how to solve this problem. However, currently we have a lot of tools that helps us to predict or at least preempt challenges that might occur in the future. What we don't do is that we don't try to find solutions before those problems come, even though we get maybe enough warning that this problem is going to happen or this challenge is going to arise. I think that as engineers, we need to start encouraging the habit of being proactive rather than being reactive in developing our innovations. For example, we've managed to develop oxytic materials for how many years now? Can we not have structural materials that have very high impact resistance produced from oxytic materials? These oxytic structural materials could help, at least keep people safe in the event of earthquake. I think it's a long walk to realize that objective, but we have somewhere to start from. The arguments, the world wasn't ready for COVID, wouldn't have happened in the first place. If we have been proactive in the way we think, there are materials we can develop as engineers that could help us, kill COVID-19 virus while lying on the surface. But we never thought about those because we thought maybe it hasn't happened yet. I think many years ago, engineers create products or solutions or develop new technologies following the linear economic model. You take a raw material, you process it, and you get a product that is beneficial to man. But we don't pay attention to the environmental impact of the process we've used. We don't care about how waste are disposed. And this has resulted into the first global challenge that we have today, which is climate change. So, but a few years ago, the idea of circular economic model became very popular, and we are moving in the right direction, now creating new products, new technology, new solutions, and following this circular economic model. We are now valorizing our waste to develop new products, new innovations beneficial to man. We are now trying to reduce carbon footprint and water footprint. In fact, most engineers are trained to understand the concept of life cycle assessment, because this gives you an idea of what kind of process you need to use when you're developing new products. What's the entire lifespan of the particular product you are using? How are waste being managed? How much fuel is going in? And how are you reducing, emissions? It's still a long walk, to achieve, but at least we're moving in the right direction. So, to really contribute to sustainable development, engineers should follow strictly the tenets of um, circular economy, which is, we have to reuse old material or old products. We need to recycle products that we think are not more functional, and we need to reduce, emissions that affect our environment. In as much as we stick to the circular economic model, we will be able to develop in a sustainable way, and we can assess every bit of environmental impact that our decision um, is having. So I think that's the only way to go. I think a resilient world is a world that is healthy. We saw that everything came to stand still during COVID because we need to be healthy first before we can drive our economy. And part of being healthy is reducing disability index. And from previous studies, we've seen that there is actually a direct correlation between, poverty-stricken regions and the amount of disability that you see in those regions. So my research is all about considering people who live with one form of disability or the other, and to see how we could develop affordable bioimplants that they can use to get back to their normal functions, and they can contribute to driving our economy and making our world develop in a sustainable manner. Africa currently celebrates Youth Bulge, which is good, but in 2050, United Nations report already show that people older than 80 years old will reside in developing countries. All countries in Africa are still developing, which means that if we are not proactive in our actions, there's a chance that we have a lot of old people living in Africa by 2050. And when we have that, we know that there is also a direct correlation between the need for orthopedic interventions and old age. So we need to create cheaper and affordable implants to help people that would live in Africa, so that they can be part of the economy one way or the other. Because if you have an elderly person sick in your family, then even the youths that are supposed to go to work, some of them will have to stay around to offer, social care and all that, because many people cannot even afford to, get people who would offer this occupational therapy and of course even physical therapy. It's important that we really reduce the disability index that we currently have. It is also important that we think of the future of the old age, that it's gonna be very prominent in our society in the future, and we can then try as much as possible to solve this problem of, um, bone diseases and all that. Should in case anyone needs an implant, they can afford it, and of course, through our medical experts, they can gain their independence as quickly as possible, and the youths that are within the labor force can also get back to work as soon as possible, rather than trying to have their loved ones at home, which is more or less our culture in Africa. Africa suffers a chronic lack of indigenous engineering capacity. How can we solve this issue? I think the problems are in two broad categories or two folds. The first fold is that a lot of young Africans do not find STEM related discipline attractive. And the second problem is that, or the second category is that we have a very huge infrastructural deficit So it's difficult to really practice engineering profession even when you're trained. And where does this lead us? Lead us to problems of brain drain, where people even get trained here and then travel abroad, get more training, and they stay back. So how do we solve this problem? Well, the first problem, which happens to be lack of interest in STEM-related disciplines. It's not only engineering. I mean, science, technology, engineering, and mathematics. That's what I mean by STEM. We need to make it attractive. And one way to make it attractive is to increase the number of outreach programs to young kids in primary and secondary schools. I did organize a Biomaterials for Africa competition last year, and I was quite impressed with the results that we achieved. This was just within Johannesburg. I could imagine if we could scale that up to something that can be done, nationally here in South Africa, or even throughout the continent. And at least people will get to know about material science and engineering, for example. I know that young kids are more curious than adults, and with their creative mind we can tap into it and help them come up with solutions that are indigenous to Africa but that are globally relevant. There is a lot of outreach programs currently going on in Africa, but we need some more of them. How did I get into STEM? For example, I was in primary school and there was this salt solution experiment that was done. So you take a cooking salt, mix it in cold water till the salt dissolves, then you put it on a Bunsen burner and the water evaporates and you have your salt back. That was like a magic to me. That simple experiment made me choose science. So mentorship is also a good one. You need to take people that have really made it in STEM field and go to these high schools and primary schools to go talk to them and you should lead by examples and all that. That could really help inspire many of these kids. The second one, which has to do with infrastructure development. I think that maybe, I don't know, but we will not stop talking to the government, but I think that it's important that government invest heavily in infrastructure for training engineers and for engineering practice. Once these are in place and you have the human resources through the critical mass of people that you are attracting to STEM disciplines, then definitely we'll start to see the kind of innovations that we want. One thing that has also worked very well, especially for people in my generation or around my age group, is that we collaborate with people who are living in developed countries and where we have all the infrastructures that you need. And this helps you to really reduce the amount of time you spend in trying to find a solution to a particular problem. So collaboration with developed countries also work, but it would be quite beneficial for the continent if some of the facilities that are available in other parts of the world are also available in Africa, and there's a partnership between the developed world and our world to then offer some training that would help increase our knowledge in a particular area, and then we can transfer that knowledge to younger ones in high school and of course in primary school. But this would not really work if the infrastructures are not there. So it's also good that the government provides infrastructure if they can, and if they can't, then we talk to the rich people to probably invest in infrastructure, engineering infrastructure, or STEM related infrastructures to help training and practice. And then collaboration is another thing that I mentioned. Thank you.